be working on 3-sum. We actually have done this question before, but it was in Java. So this time we're going to do it in Swift. Now, because we've done this before, so I'm going to be brief with the solution here, and just gonna jump. I'm going to be brief with my thought process and just going to jump right into the optimal solution. So yeah, let's start the timer. Okay, now I'm doing this in the lobby, so I'm not sure if you can hear me, so I'm not going to be as energetic as I was before, but we'll see. So given a integer array sums, return all the triplets and such that I is not equal to j, I is not equal to k. No, so 3 different indices, and j is not equal to k, and the sum of these three numbers is 0. So it's very simple question. No, simple question, but not a easy implementation. So since this is a medium question, we're gonna do it in 25 minutes. So let's look at this array: -1, 0, 1, 2, -1, -4, and then we have output of these two. And if there's nothing, then we'll output nothing, and if there's a 0, if there's less than 3 numbers, then we'll return an empty set as well. So okay, so for this question, first of all, we're gonna sort this array, and which will take n log n time. And once the array is sorted, we can, for each integer, we can use the 2-pointer method for the rest of the array, and we can do 0 subtract our current number, and then we use the remainder to see if the other part of the array has 2 numbers whose sum is equal to the remainders. And this will, so sorting will take n log n, and because for each number we have to go through the 2-pointer method, so it will be n times n. So it will be n log n plus the runtime will be n log n plus n squared, so big O N. Okay, so let's get started. So first of all, if this is less than 3, then we'll return an empty set. Else, okay, we can create a result set. Okay, so first of all, we need to enter a for loop for every single indices. I'm still being influenced by Java syntax. For syntax in 0 less than should be okay. So first of all, we need to sort the array. So now we cannot modify the array coming from parameters, so we have to create a new array to store the result of the sorted array. So this is something unique about Swift. Okay, now is it sorted or sorted? I'm not sure. sorts the collection. So this is not what we want, because we wanted to return a new array. Sorted new. Okay, so it's sorted. Sorted. You have to give it a sorted students. Okay. Yes, that's right. So sorted. And is sorted nums that counts. Now, because for every number we're gonna check the remaining part, so we have to leave at least two numbers in the iteration, so which is -2. And okay, so here we are going to have a head and tail. So it's going to be head is equal to index. Oh wait. Now, first of all, we have to make sure that because we're iterating, because there should not be any duplicate triplets. There should not be any duplicate triplets. We need to make sure that we haven't. This is a new number that we are iterating instead of a duplicate number, right? So first of all, we need to check if. First of all, if this is equal to 0, this is okay, or sorted nums index is not equal to sorted nums index -1. So make sure that they're not different. Okay, so let's see. So now we can get the head, which is index +1, and tail is going to be sorted nums count -1. Okay, and while head is less than tail, first of all, we're going to get the sum. We're going to get the sum of tail and head. So the remainder is, let's get the sum first. It's going to be sorted nums head plus sorted nums tail. Okay. And our target number is going to be 0 minus sorted nums index. Okay. This is what we want, right? Okay, so Okay, so if sum is equal to target, which is something we want, then we will, of course, we'll add this to an array. So it's going to be let result is equal to sorted nums index sorted nums. You know what, it's kind of long if we do it this way, but I guess it's fine. Head sorted nums tail. Okay. Alright. And we're gonna append this result to the results. Okay. But that's not the end yet, because after we have found the numbers we want, there might be more sets, right? There might be more tuples. So we need to keep advancing the pointers. So, but there's another thing we need to care about, is that we cannot have duplicate sets again. We cannot have duplicate sets. So we need to make sure that the pointers, that the number that we are going to move to the next time is not going to be the same as the number that we just went through. So what I mean by that is, well, okay, head less than tail, and head is not equal to, well, head is equal to, sorry, sorted nums head is equal to sorted nums head plus 1. Then we'll do, and move this a little bit to the left. Okay. Then we'll do head plus equal 1. So if the head it's equal, if the next number is equal to the head, then we'll keep moving forward. Well, head less than tail, and sorted nums tail is equal to sorted nums tail minus 1. Then we'll do the same thing. Okay. And at the end, we'll still need to move the head and the tail forward. Okay. Otherwise, if sum is larger than target, which means that we need to move, we need to make the sum a little bit smaller. So tail will move forward, or else head will move upward. Okay, that's pretty much it. 10 for 11 minutes. Let's just submit it. Okay, no file return. Okay. Oh wait, I forgot to add the return. Alright, fine. This is stupid. Okay, so accept it. Okay, cool. All right. Okay, so let's see how it is. Success. Okay, faster than 57%. Okay, cool. So this is I think this is a literally medium question because it has a good volume of code compared to easy questions, and it does require you to think through the solution before jumping to coding first. So in this case, in this video, I'm kind of like jump right into the optimal solution, which is not what you do in a real interview. So I'm here just trying to practice my Swift with the same question. But if you want to get to know how I thought through the process for this question, you can check out my other 3-sum video in Java. So I had a more detailed thought through process. But anyways, thank you for sticking to the end, and I'll see you in the next video.